Hi everyone, I'm sorry I'm not there today, but we're going to talk about the second part of section 3.1. And if you were following along yesterday and if you did your homework, then this should go rather smoothly. So let's just go ahead and get in there. So yesterday we talked about how to graph exponential functions, right? We graphed things like f of x is equal to 2 to the x. F of x is equal to 1 over 3 to the x, and so on and so forth. And you can see that the base here can really be any number, any constant, right? Well, today we're going to talk about the one special base that is the basis for so many real-life applications. And that base is called the natural base. That's how often it comes up. It's just the natural base, right? And this natural base is actually an irrational number e, okay? It's called the natural base. Where does it come from? A little bit of background for you. If you graph this function, 1 plus 1 over x to the power of x, it turns out the graph of it, starts to increase and then it plateaus at a certain place. Turns out the y value where it plateaus is 2.718 and so on. And that special value is what we call E. All right? Why do we call it E? Well, it's named after the mathematician Euler. And because it's named after him, it gets the value, the symbol E. All right. So E is 2.718281828. It's an irrational number. It never ends. It's like pi, okay, 3.14, blah, blah, blah. Now this is, its cousin E. All right. So what we're going to do now is we're going to graph functions with the base E. And if you look here in the instructions, it says to use E equals approximately 2.7. Okay, so we never saw that. It was never there. We're going to ignore it. We never saw it. That's not what we're going to do. Okay? All right, so let's graph our very first one. What I have here is the following. I have f of x is equal to e to the x, and just like before, y is equal, the asymptote is y equals 0. The y-intercept is y equals e to the 0, which is 1, 0, comma 1. And we're going to go ahead and graph this one. So first, notice this is, growth again, because it's e, which is greater than 1. So I chose these values again. And so now I have e to the minus 1. And what we're going to do here is plug this into our calculator. So we're going to get E, right? Okay, so E is this button right here, left-hand column towards the, middle here. E to the power of, we have negative 1, and that is 0.368. Okay, so it's enough to just do 0.37. Okay, and then I have e to the 0, that's just 1. E to the 1, remember e is 2.7, so that's just 2.7. E squared, if you put it in the calculator again, it's 7.4. Okay, so let's go ahead and put in our asymptote. And I have at negative 1, y is 0.37. 0, it's 1. At 1, it's 2.7, and then 7.4. And that's how that looks, right? So you see it doesn't look any different than any of the other ones because, there is not really that much difference. The domain is still all reals. The range is y is greater than 0, just like before. All right, let's do another one. So here I have e to the 2x plus 3. Right? And now look at this one. The plus 3 moves everything up 3 units. So the asymptote is now y equals that value of 3. The y-intercept is e to the 0 plus 3, and that's 4. Okay, and here we're going to put in our values. So it's e to the 2 times negative 1 plus 3. And let's go ahead and put that in here. I have e to the negative 2 plus 3. So e to the negative 2 plus 3, 3.13. So 3.1 is good enough. And then here I have e to the 2 plus 3. E squared is 7.4, so that's 10.4. And then next I have, oh no, I'm sorry, I did that wrong. That was supposed to be here. E to the 2 times 1 plus 3, that's 10.4. So here I have e to the 2 times 0 plus 3, which is just 4. And finally I have e to the 2 times 2 plus 3, right? That's e to the 4 plus 3. And again, you're just going to put that in your calculator, and you're going to get a whopping 57.6. Okay, can we figure out what the domain is here? Yes, we can. It's all real numbers. Can we figure out what the range is before we graph? Well, my y-intercept, my asymptote is at 3, and this is a positive number here, so it's going to be y is greater than 3. All right, so let's go ahead and put in our asymptote. And so when x is negative 1, y is 3.1, and then 4, and then 10.4 is just there. I'm going to cheat and go ahead and use it. I have 3 points. That's good enough. And let's go ahead and graph that way. Okay? All right, let's look at the other one. Now I have a negative out front, and that means it's going to lie on the bottom of the asymptote, which means it's going to affect the range. But the asymptote is still y equals 0. The y-intercept is y equals negative e to the 0, negative 1. All right, and here what I have is negative e to the negative 2, and that equals, when you put it in your calculator, negative 0.1. I have negative e to the 2 times 0, negative e to the 0, negative 1. I have negative e to the 2 times 1, negative 7.4. Negative e to the 2 times 2, that is a huge number again, negative 54.5. Okay, where did we say the asymptote was? At y equals 0. Okay, when x equals negative 1, we're at negative 0.1. Then negative 1, then negative 7.4, and that's good enough. Okay, and our domain is all reals, and the range you can see is now y is less than 0. Okay, perfect. All right, and that we're almost there. I only have one more to go. So here I have an asymptote of y equals negative 4. Oops. The y-intercept is y equals negative e to the 0 minus 4, negative 5. Okay, and so let's see here. When x equals negative 1, y is negative e to the negative 1 minus 4. And that's negative 4.4. I've already plugged these into the calculator, but let me show you. Let me show you how to do this one. It's negative e to the power of negative 1 minus 4. Right, negative 4.4. For x equals 0, is negative 5. Next, when x equals 1, we have negative e to the 1 minus 4, negative 6.7, negative e squared minus 4, negative 11.4. Okay, asymptote is at negative 4. The domain is all real numbers. The range, I have a negative here, so it's going to be y is less than the asymptote of negative 4. Okay? Let's go ahead and put in our values. At negative 1, we're at negative 4.4, then negative 5, then negative 6.7, and 11.4 is too far down, so there you have it. Okay? Alright, so that's pretty much that. The homework is the exponential graphs handout, and you can see on top of it, it says assignment number 2. And I really want you to keep track of these assignments so that you know which ones to turn in at the beginning of the week. Alright, have a great rest of the day, and I will see you guys tomorrow.